in class. So if you have those with you, whip them out. If not, bring it with you next time and or using your homework. And if you don't have one at all, get one from the library. Get one from the library for free before they're all gone. Next week they'll probably be gone. All right, so x cubed minus 4x plus 1. Let's see, x cubed minus 4x plus 1 equals 0. We're going to use our graphing calculator to solve that thing. Why? Because it's really hard to solve without it. I don't know if you know. That's a super hard equation to solve by hand. In fact, I don't know how to do it. I don't know how to solve that by hand. X squareds we can do, right? X squareds we can do with the quadratic formula. You can solve any x squared with quadratic formula. But x cubed, is there a formula for x cubes? There is, actually. It's called the cubic formula. There is a formula out there. I've never used it. I've seen it. You can type into Google the cubic formula. You'll see it. It's awful looking. It's just horrible. Makes the quadratic formula look like child's play. It's really, really, really complex. Now, what if they'd made this fourth power? Is there a formula for fourth power? I can never remember the answer to this question. I think it's yes, but it may be no. So that's helpful, huh? Anyway, it really, at the least from the fifth power up, let me see if I wrote it in my notes somewhere. Did I write it? I said, I didn't write it. Okay. Anyway, whatever. So somewhere, fourth or fifth, I can't remember which one, there's no formula. So there is a formula for, x squared, the quadratic formula. X cubed, there's a formula called the cubic. It's awful. I've never used it, but it's there. It's available. You could do it. You can solve any x to the third using the cubic formula. But either at the fourth or the fifth, I can't remember which one, there's no formula from there on up. So my point is, the main point is, at some point, there's no formulas, either starting at the fourth power or the fifth power. There is no formula for solving it by hand. You need to use technology. So as part of what I want to teach in this class is how in real life math and science is done. What's the role of technology? What's the role of by hand work? How do they work together? When do you do one thing? When do you do another? That's a lot of what we want to try to really get comfortable with. Not only starting at the fourth or fifth, I can't remember which one, and on up, is there no formula for solving? But you can type into Google, you can probably have the question in 10 seconds here. But somewhere, fourth or fifth power on up, there's no by hand formula currently, and there never will be. It's not a matter of we need to do more research. It's been proven that none could exist. Isn't that interesting? Isn't that bizarre? How can they prove that something doesn't exist? There's a whole area of mathematics called existence studies. And they prove whether something even could exist or not. And they have proven. They have proven that there's no formula for, like I said, I can't remember, fourth or fifth power on up. Never could be written. Never. They were looking for it for a long time in the 1700s, I think it was 1800s. They were looking for it. They had the second power, they had the third power formula. And again, I can't remember, fourth or fifth. They were looking for the next one, and they were starting to believe it might not exist. And then a young man named Galois, I took his class when I was at not his class. I took a class with his book. He's from the 1800s. I took Galois theory. Galois proved that it couldn't be done, that there would never be a formula, fifth power and above. It's impossible to actually make one, which is weird. Like, how do you prove it's impossible to make a formula? Well, I don't know. It's very complex math, way over my head. Galois proved it when he was like 21 or something. Super young, like genius boy. He proved it like big old mammoth 200-page paper. And here's the trick, though. He tried telling people, I proved it. It was a big, everybody was studying. He tried telling everybody, look, I proved it, but nobody believed him. Nobody would want to take the time to read this gigantic 200-page paper of somebody that was yet a nobody. Does that make sense? In other words, even the great mathematicians, in fact, he sent it to the big shot of the time. The big shot is still pretty much the big shot, Carl Friedrich Gauss. He sent it to Gauss, who was, the number one, probably one of the best mathematicians ever. But everybody sends their stuff to Gauss. He got it in the mail, 200-page paper from a nobody named Galois. He's like, whatever. He just set it aside. This young 21-year-old French kid sends me this 200-page paper. He just sets it aside on his shelf. He doesn't read it. So Galois like, man, nobody will believe my proof. So he starts cruising around to math science fairs or conventions there in Europe in the 1800s. And while he's cruising around trying to show different math science people his proof to get it known, he catches some disease at these events and dies without ever receiving credit. And then after he dies, Carl Friedrich Gauss gets out the 200-page paper, reads through it, and goes, he did it. He was right. It's a good proof. So after death, posthumously is how they say that, right? Galois got credit. So my point in all that is we must have technology. We can't do and it's not just a matter of time. We'll never be able to solve fifth power and above by hand. We have to have technology help us. So technology does play a vital role in math and science work. It always will be. That'll never go away. So let's use it. So how do you do it? How do we use technology to actually solve this thing? Well, if you have your graphing calculator, what I'm going to do, and they're all a little different. I'm using the TI, but like I think I advertised, the Casios are just as good. So I'm going to be using the TI. I'm going to put this into Y1. In fact, I could throw it up here on the Elmo, I think. So let me do that. Here, before I do that, let me write what I'm going to do on the screen. So I'm going to put into Y1 this function, x cubed minus 4x plus 1. I'm going to put it into Y1, and then I'm going to graph it. Is this making sense? So I'm going to put this function into Y1. I'm going to go Y1 equals, and then I'm going to graph the thing and see what it looks like. So let me go back, and then I'll ship you a YouTube is what I'll do. So you graph the thing, the window. It probably just would have worked. You know, I did a lot of work on that window, probably more than I needed. Negative 10 to positive 10. Negative 10 to positive. That I know I did 5 and 5 for the x, but probably that would have just worked fine. So I'll just write it that way. I think if I had done that window, it would have been fine from the beginning. So put that in for your window, and then you have to graph it. And when you graph it, what did the graph look like? It looked like this. You got to find that, and that. Those are the zeros, and you've got to hit, at least on the TI, you've got to type in. So for the TI, which most people have, but the Casio is great. You go ahead and get that. What is it? So I'm trying to remember what it is I did. Second calc. So you do second calc, and then when I hit second calc, and then choose 0. And then after I choose 0, I go left of it, right of it, a guess. So this is what I mean by left of it, right of it. This would be left of it, right of it, and then this would be your guess. Left, right, guess for that one. That makes sense. And then you got to redo it for the second one and go left of it, right of it, guess. And then you got to redo it for the third one and you go left of it, right of it, guess.
Would it matter on where you put your guess as long as it's like in between the lines?
It doesn't. Yeah, good question. It doesn't matter where you put the guess. It's just where the calculator starts looking.
Okay.
Anywhere in between the left and right is fine.
Okay.
Yeah.
Is the little part that you did right now on the calculator going to be on your YouTube video?
No, see that's the problem. Yeah, because I used the Elmo, so this was not on there. But that's what I'll do is I'll ship you a YouTube somebody else did.
Okay.
Yeah, they're out there. And so let me show you that real quick. That's probably worth your time. So questions on that before I move off on that, how to find those? So yeah. Yeah, let me give you a second way, which I don't know if that's going to be more helpful or make it worse. When I was first a brand new teacher, I thought, you know what? I'm going to be helpful. I'm going to show everybody like 2 or 3 ways to do all the problems. That confused everybody. Everybody hated that. So anyway, I learned that students prefer one way done over and over and over and over and over again. But having said that, I've got to break that rule every now and then. I'm going to show you a second way, which is kind of easier. And you might wonder why I didn't just do it the first time. I don't know. But here's another way to solve. So they want me to solve this. You can just let y1 equal the left side. Yeah, I probably should have showed you this in the beginning. And y2 equal the other side. Yeah. And then you do the intersecting. Here, let me pause this again and go back. Here, I'll send you a YouTube for that as well. So where are we at? So you just put them both in. So number 1, type them in. Number 2, graph them probably x min, x max, negative 10, positive 10, y min, y max, negative 10, positive 10. Again, I'll say this is maybe. Maybe. That's just a maybe. On this one, yeah, it works. But sometimes you need to change the window. That's the major issue for people, is the window. When you need to fiddle with the window, that's the main trouble people have. So make sure you can do that before the test. So then number 3, you choose second calc on the TI. This is TI instructions again. Second calc, and then what was it? Intersect? Intersect. And then just first curve, just hit enter. Second curve, just hit enter. And then guess, move near intersection. Move near intersection. Move near first intersection and hit enter. There we go. There's the instructions for the TI anyway. So I'll send you a YouTube that says it a little more clear and better than I'm saying it. Questions on that? That makes sense? We good with that? Solving equations. There's probably other methods out there. Feel free to search YouTube. There's probably methods where you don't even need a graph. But it's good to practice. We'll need a graph for other things later. Just do that all the time. At least for the TIs. The Casios are even nicer. Casios, I don't think you even have to draw a picture. You can just hit a button and it just solves it for you, if I remember right. So x to the 4th minus 3x cubed plus 6x minus 1. So again, I would just let y1 be that and just let y2 be 0. Just let y2 equal 0. And let y1 equal the x to the 4th minus 3x cubed plus 6x minus 1. And do the intersect thing. Yeah? You can just do it that way. You can just always do the intersect thing. y1 left side, y2 right side, and then do the, the thing we just did with the intersect. That's easier. So that'll work fine. I just used up all of our time on graphing calculator talk, so let's do what I can with these few minutes left. 20x plus 32. What are the steps for solving x squared? Do you remember? Solve an x squared equation. Number 1, you've got to get a 0 on one. So this is by hand. So these you're having to do by hand. It just says verify it with your graphing utility, but we still have to solve it by hand. So this would be the kind of question I would give you on the no graphing calculator part of the test. You do have to know how to do this by hand. So step 1 is you get a 0. Step 2 is you try to factor. And step 3, if it won't factor, then you use the quadratic formula. Remember the quadratic formula? I don't think we need the quadratic formula in this section. I think they'll all factor. But some people just like to use it better anyway. Feel free, either way. So there's the game plan for how, if you remember from algebra, how you solve x squared equations. You get a 0 first off, right? This is x squared, not just x to the first, right? So you got to get a 0, try to factor, and if it won't factor, you can always use the quadratic formula. All right, let's do it. So I got to get a 0, so I'm going to grab this 20x and jump it to the other side, and grab this 32 and jump it to the other side. What happens when things jump over the equal sign? Switches signs, right? Because really I'm just subtracting 20x and subtracting 32 from both sides. But to save time, from now on, I'm just going to jump them and say, hey, they switch signs, right? That's what happens. So then we get 3x squared minus 20x minus 32 equals 0. Right? They switch signs when they jump to the other side of the equal sign. And then we factor. Now, I know that people need a lot of review usually on factoring, and I've only got 5 minutes. So how good are you at factoring? There's a million ways to factor. I don't care how you do it. I'll just show you what I usually do. I just usually write the word FOIL and couple parentheses, and I just start guessing. I don't think more fancy than that. I know there's all kind of ways. Whatever you like, the diamond method, whatever. Front times front. Front times front. to make 3x squared. That's what the word FOIL stands for, front times front. L stands for last times last, last in this parenthesis times last in that parenthesis, make 32. What times what's 32?
4 and 8.
A lot of things. 4 and 8, 2 and 16. What should you start with? Usually start with the numbers closer together. It's usually them. 4 and 8 are closer than 2 and 16. So I'll try 4 and 8. 4 and 8. Oh yeah, that's going to be right. I want to do it wrong at first so that you see how you know when it's wrong. Oh, wait a minute. Which way is wrong? No, yeah, I'm correct. This is wrong and the other's right. Okay, so let me show you. So how do you know whether that's right or wrong? Everybody with me so far? Let me erase this. Make sure you have room here. If you didn't get the quadratic formula, it'll be on the YouTube. So bring it up here. 3x squared minus 20x minus 32. FOIL. So I'm doing front times front, last times last. So 3x regular x, 8 times 4. Now, no signs yet. Hold off on the signs. How do you know if that's right or not? Well, you got to check the middle, the oi. What does the O and the I stand for in the word FOIL? Outer with outer and inner with inner. So what's the two inner? 8x. What's the two outer? 12x. Can they make the middle negative 20x? Yes, but how do they make negative 20? They'd have to both be negative. Right? You'd have to lose $8 and lose $12 to lose $20. So that's it then. No, it's not, because if you made them both negative, negative 8 times negative 4 is not negative 32. Remember, they're supposed to multiply to be this guy. So we can't have two negative. Right? So that's not right. Well, what do? That just means whenever something's not working at first in this factoring thing, the first thing you should always try, guys, is switching the order. So I switched the 8 and the 4 there. Now try it again. Now the two inner. Again, no signs yet. Wait on the signs. Wait on the signs. So now the two inner make 4x. The two outer make 24x. Now can they make negative 20? Yeah. The sign in the middle always goes on the bigger guy. Right? So the 24 is the bigger guy, bigger than 4. So it's got to be, and the negative, so he's got to be negative, and he's positive. Plus, if you gain $4 and lose 24, you lost 20. That's working. So this sign goes right there, plus, and this sign goes back there, and plus 4 times minus 8 is minus 32. It's right now. Do you see how everything checks out now? Now that's hard for a lot of people. You got to master that, especially if you're headed to calculus. I remember my daughter when she's taking pre-calculus. I said, I hate factoring, Dad. I hate factoring. Well, you better get good at it. Was my answer to her constantly. So you got to learn it. You got to get good. So hold on. I need these 2 minutes. We can't be throwing away minutes. Hold on. We need every second in here. So okay. So now, with all that done, now how do we finish from here? We set each one equal to 0 separately. Right? What? Because if two things times to be 0, right? These are two parentheses timesing to equal 0. If two things times to be 0, either one could be 0 to make that happen, right? 0 times anything is 0. The first one could be 0, because 0 times anything is 0. Or the second one could be 0, because anything times 0 is 0. So the first one's 0, solve it, jump the 4 over. 3x is negative 4, divide by 3. Jump the 8 over, x is 8. There's our two answers, negative 4/3 and 8. You could have got them out of the quadratic formula, which is easier for a lot of people, really, than all this factoring. If you wanted to just use the quad, negative b, plus or minus, that whole thing, you could do that too. That's fine with me. Let me just glance to make sure I can assign this to you.